AI Data Bytes, powered by Denodo. Welcome to AI Data Bytes, powered by Denodo, the podcast where we explore technologies, strategies, and real world challenges shaping the future of enterprise AI. AI is rapidly evolving beyond simple chatbots nowadays. So, like today's AI agents can reason, retrieve information, call tools, and take autonomous actions. But as enterprises move towards more advanced agentic AI systems, a new challenge is emerging: the hidden cost of intelligence. Every interaction, every retrieval, and every reasoning step consumes tokens. And without the right architecture, these costs can quickly multiply. In this episode, part 1 of our two-part series on the economics of agentic AI, we take an architectural view of the challenge. We'll explore lower cost, higher trust, the new economics of agentic AI, looking at why token economics matter, where enterprises are losing efficiency, and how organizations can build AI systems that are more cost-efficient, governed, and trustworthy. Joining us today is Dominic Sartorio, VP of Product Marketing at Denodo, an expert in data architecture and agentic AI. Dominic, welcome to AI Data Bytes.
Thanks for having me, Neha. And I agree, this is a really important topic. We see many organizations are implementing agentic AI, excited by what it can do for their business, and they're only now beginning to understand how costly it can be, and they're struggling with how do they keep those costs under control.
Definitely. I agree with you, Dominic, and wonderful to have you here. Today's discussion will be focusing on shifting towards a business perspective, exploring how organizations can evaluate the ROI, business impact, and strategic value of building more efficient AI systems. So I'm really excited to get started with today's conversation, Dominic, but let's start with the basics, shall we? So we keep hearing about token economics nowadays. What exactly does this mean, and why has it become such an important conversation as enterprises start adopting to AI?
Yeah, so first, let's distinguish between basic chat, like the generative AI, that was popular when ChatGPT first came out like 3 years ago, and agentic AI, which most organizations are implementing now. So in a standard chat kind of interaction, you just ask a question, the model processes it and gives an answer, and that's it. And you may have follow-up questions and answers, but the context, so the number of tokens that are available for that LLM to process, will grow only gradually as there are more questions and prompts given. It'll grow linearly, essentially. But with agentic AI, it's different. So agents, usually multiple agents are operating together through a multi-step workflow. So for example, you could be agentifying a customer support process or a customer onboarding process. And you may have distinct agents that own distinct pieces of a broad and fairly complex business process, which then is automated through a single workflow. So if any agent in there is somehow aggregating or accessing more data than it needs, or it's the incorrect data, so then it has to retry and query again, or it has to pull data from a lot of different sources, and then it has to join from those sources. So anytime an agent has to do that, that creates unnecessary additional context that it then makes available to the LLM. But then if you have multiple agents in a workflow all guilty of those things, then that excess baggage, as it were, it just compounds one after another, and it compounds almost exponentially. So that's why with agentic AI, organizations have really been hitting the token consumption wall way more than they did with previous generations of AI. And those costs go up the more complex the workflows get, and the more data from more data sources that you need to feed to those agents in order for them to do their jobs.
Wonderful. That's a great summary. So, kind of deep diving a little bit more on the token economics aspect of it. Why do the costs related to token consumption grow exponentially in agentic workflows compared to traditional AI interactions?
Yeah, I can double click on that.
Mhm.
So let's give a practical example.
Sure.
Like, let's say I'm automating a customer onboarding process, and a customer may have interacted with several parts of my organization before actually becoming a customer. They may have talked to one of my sellers at a point of sale. They may have gone online to my website. They may have chatted with one of my staff on social media. So in other words, there may be several different data sources where that customer's data may appear. And now suddenly I kick off this agentic workflow, and an agent has to query all that relevant data from those various sources to form a complete picture of that customer so that it can then do the right thing. Well, how does it know which of those sources it should pull from, which specific records it should pull, how that data across those sources relates, like how you join them? So, and if you're sloppy in how you access and provision that data, then you can easily generate too many tokens as a result of it. Like you're accessing too much data from each source. You're not joining them properly, or the joins might be getting done by the model itself, which is particularly expensive. So then right away, agent one hasn't even finished its job yet. You already have too much context for multiple reasons. Now agent one hands off to agent two. Maybe agent two is doing initial billing or something. Okay, now you're accessing yet more data sources, a financial app, and accessing maybe some payment processing. So yet more systems that you have to join. And then have to join that with the context the first agent already created. So that's just a practical example of how, if agent one isn't smart about what data it's accessing and when and how, it can easily generate too much context, which then gets passed along to the next agent, which is guilty of the same problems. It's not smart about how it's accessing and processing whatever data, and then it's multiplying that with the first agent's context. So that's how, in practice, token costs can just exponentially go up as a workflow is executed.
Thank you, Dominic. That was a great explanation. What are the misconceptions companies have about managing token usage or consumption?
Yeah, I think the misconception is what most organizations is the action most organizations believe they need to take. The CFO gets that token bill, then he goes to the AI teams and says, "Hey, you got to you got to produce fewer tokens." So then the AI team ends up thinking, "Okay, how do I reduce fewer tokens? Maybe I just don't access that particular system anymore." Right? Or maybe I just don't do retries if I'm not sure of my answer, right? They'll end up compromising by giving their agents less context, just in a brute force kind of way. But that's often not the best answer, because you're not really helping your agents then produce the right answers. You're not giving it the data they need in order to produce the right decisions and actions. So the misconception here is, okay, let's just go around and find various ways just to reduce token costs. But the right answer is not like, let's cut systems or reduce queries or any of those other things. The right answer is making sure that whatever data is returned, whatever data is the result of those particular queries, is already the right data before it even becomes a set of tokens. Right. So in other words, it shouldn't even be the AI agents or the model's responsibility to think of, okay, am I getting the right data? Am I joining it properly? Am I interpreting it properly? Because that's where the token costs start to run up. Instead, it should be the job of an underlying data platform to ensure that the right data is being returned in the right way. So then you're going to have certainly less quantity, but within that quantity, you're more assured it actually is the right data, and that's how you can reduce token consumption in the long run. So the misconception is, all right, let's just have the agent do less, query less, one less system, join less, process less, and that's not really where the problem is. The problem is in the underlying data being returned, and if you're smarter about that, then that's how you can reduce tokens while still ensuring your agents are giving the right answers.
That makes a lot of sense. Thanks, Dominic. And I believe it must be tricky to also manage this at an enterprise level. And that brings me to my next question. So, why does enterprise data complexity create hidden token costs for AI agents? What are your thoughts on this?
Yeah, this is hard in the enterprise because in the enterprise, data is going to be highly distributed, right? Like earlier, I gave you just that one simple example of onboarding a new customer, and that customer's data may have been in three different sales or marketing systems, and then you have to bill them, and that's a fourth system. I mean, that really is a very simplified version of what's happening in reality. On average, and we did a study on this, the AI Trust Gap report published a few months ago. an extensive survey worldwide, and the average enterprise has over 400 distinct data sources that from which they need to pull data to feed their AI agents. I mean, that's huge. Another misconception is, hey, all of that data I can just aggregate into a single data lakehouse or a database, or I can put all the right embeddings into a single vector database. In other words, let me just put all my data in one place, kind of simplification fallacy. And then that's how I can provide less data or just the right data to my agents. The reality is not that. You're never going to get all your data centralized in one place. And even if you could, then it's not the live real-time context that most agents are going to need. So in short, it's the distributed reality. And if you end up going down the path of your AI agent developers just putting MCP servers around each of those data sources, then you're not solving the problem. You're just creating integration complexity all over again. This time it's your model that's trying to deal with it and join that data the right way. And that's one way your token costs run up. So I think the root cause is just the distributed nature of data and the fact that many AI teams are just trying to hit each data source or each domain of data just individually, independently, without there being some rationalized or unified view that they could access instead.
Thanks, Dominic. Does MCP even solve these problems, or does it bring a new set of challenges with itself? So, when we are trying to integrate, understand the technology that integrates these fragmented sources of data, what is your opinion on what should the technology be like behind this?
Yeah, well, MCP by itself is not the problem. Instead, it's a misconception of the scope of what it can handle.
Right.
MCP, Model Context Protocol by itself, all it is, it's an interface by which AI can access underlying enterprise data or enterprise applications, right?
Mm-hmm.
It's an interface point. It's just a point of access for anything that the whoever built that MCP server could have decided to put behind it. By itself, it's not an integration platform, right? It doesn't do distributed queries or complex queries. So by itself, it just
Mm-hmm.
does not do that. So thus it does introduce the new challenge where if an AI team goes down a path saying, well, my answer to data integration is MCP, right? And then they just slap MCP servers around each data source independently. Well, then that's how you actually create that integration problem. You've got too many data endpoints, and then you're putting too much complexity in front of your agents. So the right answer is have the right data integration platform in place first, right? And then you can put an MCP server on top of that, right? So you let that data platform handle and solve for the distributed nature of data, and then be able to provide single views of that data. And then you can have a single MCP server on top of that, delivering that common view, or much fewer MCP servers than you otherwise would. The term I'm starting to hear is MCP sprawl. So AI teams that don't do this, they just they find a new data source. All right, let's put an MCP server in front of it, and then quickly you're going to get to those 400 plus that I mentioned earlier. That's the sprawl. You just have way too many of them, and then you have an agentic AI workflow accessing each one of those independently, not sure which one is the right one, then having to do joins across all of them. That's where the token costs run up. So the right answer is to basically push that complexity down behind MCP, and then having much fewer MCP servers that your agents have to deal with.
What are the biggest token tax traps enterprises face when connecting agents directly to their data?
Yeah. So let's take as a given that MCP sprawl is what's
Mm-hmm.
happening in the organization. And I can double click on, given that, what are the various ways you run up your token costs. So first, if you've got a lot of MCP servers, most likely each of them will have their own metadata. You may have many semantic layers, as it were, spread throughout your company. So the first thing an agent needs to do, it needs to discover, where do I need to go to get the right data, right? So it may be accessing different semantic layers in the form of different catalogs and different schemas, trying to figure out, okay, which MCP server or combination of them I need to access. And And if those different catalogs and schemas don't agree, like the semantics are different, then that results in having to access many of them until you can discern, okay, have I discovered the best data, right? And so just that act of discovery can result in a lot of tokens. The second problem is if you're doing the joins, if you're processing that data, if that's being done by the model itself, right? So let's say I've got to join that customer data across my social media marketing system, my website, my point of sale app, my billing system, using the same customer onboarding example I gave earlier, right? But those were 4 MCP servers that each just throw up there the raw data coming from each of them. Where does the join happen, right? How do you create that single view of that customer, right? If the model is doing that, that's a lot of computation you're making the model do. And that will also generate a lot more tokens. And that one's really, I think it's really the biggest one from what I can see of all of these token taxes, because that joining, basically executing a distributed query, can essentially be done for free by a modern data platform, right? And so you could bring that tax almost down to zero. There are other taxes, like if the agent executes and then it generates an answer, and then probably in that workflow, you have multiple ways of checking the validity or accuracy of that answer, and you might find it's the wrong answer because you sourced the wrong data in the first place. Okay, now you're doing a retry, right? You're having that agent, rediscover and retry fetching the right data so that it can generate a better answer the second time around. So those retry loops can also add up token costs. And the final one, and maybe not the biggest one in terms of cost, but it does add to just overall governance and risk, is what I call over retrieval, right? It's like issuing that select star when you could have been just selecting specific records from a data source. Or you may not have had the best access controls in place, so that the agent is actually accessing more data, or it's accessing certain fields that it should not be. So, so this is another example where actually, if you reduce costs, you can actually reduce risks.
Thank you for painting that picture right from the MCP sprawl that organizations are seeing, right to the need for an integrating technology or a layer to these aspects that we covered related to token tax. So, how does the active context layer change the way AI agents access and use enterprise data?
Right. Yeah. Thanks for bringing up active context. So that's exactly what the Denodo platform does. The Denodo platform is a single AI data layer. That single layer, that single MCP server that you could have, regardless of how many data sources you have. And what the Denodo platform then delivers to your agents is that active context. What is active context? It is a single unified context layer. So single source of truth of what your various data means. But that context layer is directly operationalized. Like it directly links and retrieves exactly the right data, the live data, so you didn't have to copy it or move it anywhere in advance. And you're also ensured that the right governance and access controls, et cetera, are being applied. So that's active context. Single source of truth for both the meaning of data and the actual live data, and being ensured it's the right data and it's well governed. So we are promoting that as the key way of reducing these token taxes and optimizing your token usage.
Thanks, Dominic. How do universal connectivity and zero copy data access help reduce unnecessary token consumption? Do you maybe have any examples that you can share?
Yeah, so I can go back to the customer onboarding example where, again, prior to an actual sale, becoming a customer, you may have interacted to them over your website, over social media, and like in a retail physical store, let's say your point of sale, 3 different systems, right? And now you're getting their credit card information so you can bill them. Okay, that's system number 4, right? And then you get a record into your customer support, your help desk system. That's system number 5. Okay, that's very simple. Now, any of those systems, your customer may have a subsequent interaction with, right? They could post something to your social media. They could do something on your website. They can make a repeat visit to your store. They may pick up the phone and call your help desk. I mean, any of those can happen at any time, right? And So, and it could trigger some kind of workflow, some kind of agentic workflow to deal with whatever it is that customer needs. Do you want that workflow to operate on the most up-to-date live data, including the most recent interaction you had with that customer? Of course you do, right? But if your AI data architecture required that you have to copy data somewhere, like copy it into a lake house for your AI to access it, well, that data is the moment it's copied, it's no longer live. The moment you've copied it, something may subsequently be happening in your original data sources that ideally your agents know about, right? And if they don't, then they're operating on stale data, and they're going to provide probably incorrect feedback to that customer, if not embarrassing, because it's obvious to the customer that you're not aware of the latest thing the customer
Right.
did with you, right? So right there, that's a good example of why you want zero copy access. So you don't want to require copying. You want that your data layer to access those data sources directly and pull out exactly the right data that's live so that the agents have the live up-to-date data. And that also speaks to universal connectivity. Like in this example, I just gave 5 systems. Again, in a typical enterprise, you may have hundreds of systems that have some data that may have some relevance to your complete view of a customer, any of which you may need to access at any time. And so, yeah, requiring upfront copying from all those systems is just not tenable. It's not practical. So you do need to have some universal way of accessing all those systems live in order to ensure you have all the right data your agents need.
So, how do unified semantics and governance improve accuracy while preventing token waste?
Yeah, so the unified semantics is that single source of truth for what
Hmm.
does data mean, right? So those 5 different systems each have a customer schema in them, right? And they may have different definitions of a customer. Like what your help desk thinks is a customer, right? Is like a customer who's already paid. They may own specific product and they're entitled to a certain support contract. Your sales systems may have a different definition. They may have a definition of customer that predated actually making a sale. Your billing systems may have another definition, like including are they active, are they current with their payments, right? So if you have different definitions of data and different versions of what that data means across systems, and that makes it harder for your AI to be certain that it's actually pulling the right data given whatever the situation is or whatever that workflow is trying to execute. That can be a source of the retries. It may have accessed data from the wrong system, and then it has to go back to a different one because of that inconsistency. It didn't know which system to pull from initially. So, but if you have that a common definition of what is a customer, then in many cases inclusive of what those 5 upstream systems entail, that's still a single common definition of truth. So there's no ambiguity. What data do I need? So that's what unified semantics solves for. Unified governance goes hand in hand with that, right? Unified semantics, that just tells you what your data means, right? By itself, it does not tell you, okay, did the data that was returned, is it clean and trustworthy data? Is that data secure? Like, did we redact the fields that this particular agent should not see? So that's where the unified governance comes into play. What's good about the active context approach is those policies can be enforced right at that point of access at runtime, right? So unified semantics tells you what to query. Unified governance then looks at the result of that query and then applies your policies right there. So redact that data that the agent's access control policies say it shouldn't see. Flag if the data quality is not good, or if the freshness is not adequate. So whatever your policies are, it can enforce them at runtime right there. And to do that in a unified way. So regardless of what data that data originated from, so all 400 plus data sources, it's a consistent set of policies that apply across all of them. So, and that also provides assurance that, okay, not just the right data, but exactly the data we're allowed to see. We trust that this data is clean and accurate. And I didn't have to care where it came from. I'm confident that those policies are in place.
This brings me to my next question. How can organizations evaluate the financial benefits from optimizing their AI architectures?
Yeah, good question. Given this is a problem getting CFO attention, the best way, probably the only way to address a finance leader's concerns is show me the numbers, right? So to that end, we did produce a model, and we published this in a white paper recently, a couple of weeks ago, our token economics white paper. We propose a model where an AI architect or team lead can plug in a set of numbers that represent their current state, right? And the current state assumes you've got distributed data, how many MCP servers you have, and so it prompts you for those things like how many data sources, how many endpoints. It also prompts you for how many agents are in your typical workflow. What is your average number of retries per agent and per workflow? How many attempts does it require for discovering the right data, and also you can put in a number representing over access or over provisioning of data beyond what access control policy say they should have. So you can provide all these inputs, and then the model then spits out, okay, given, let's say we solved for the fact that your data is distributed and you had multiple endpoints. Let's say we solved for the retry problem because you got the right data in the first place. We solved for the multiple discovery problem because you had unified semantics and so on. Then what is the resulting token reduction? So we did do a baseline just based on our own anecdotal knowledge of what our existing customers are doing with us. Of course, your own mileage may vary, but in that baseline, we found that by using Denodo's approach, active context, we reduced tokens by 85%. And to be
Oh,
clear,
wow. Okay.
tokens that are specific to, yeah, it was a surprisingly big number
Mm-hmm.
when I ran them the first time. To be clear, these are tokens generated through through your accessing, provisioning, and processing of data that your agents need. So and that's often where your token cost is running up actually. So we could reduce that by 85%. Now again, your mileage may vary. If you have fewer or more data sources, fewer or more semantic layers, so sources of business meaning, the complexity of your workflows, yeah, and the frequency with which your agents are running. Like an agent that's running once a day, of course, is going to generate less token tax than an agent that's running, say, once a minute. So all those are inputs. But yeah, 85%, it was a surprisingly big number. And so that's a lot of tax that enterprises all over the world are paying, right? And we've seen token economics in the news. It makes CNN and CNBC, at least what I've seen here in the USA. Executives and boards of directors are worried about just the sheer cost of tokens and the sheer cost of running AI. And so far, too few are kind of looking at, well, is it really a data problem, right?
Mm-hmm.
Are we in fact smart? Can we be smarter about giving our AI fewer endpoints to look at, having a single source of business meaning, ensuring that it's only retrieving exactly the right data and being confident it's the right data? So that hasn't yet entered the lexicon of many C-level execs and boards who are worried about token costs. Instead they just assume it's an AI model problem, right? Or maybe Anthropic or OpenAI are charging too much per token, right? And so then they'll put pressure on those vendors. And there's basically a dog that's not barking, right? And when you watch the news, and that dog is just like, you can be a lot smarter with how you're managing your data and how you're making
Mm-hmm.
data available to your AI.
Thank you so much
Mhm.
for highlighting some of the key points that were mentioned on the token economics white paper. Thank you, Dominic. And
Yeah.
for our listeners, and as we come closer to the end of this episode, apart from cost savings, what are some other business benefits you can highlight that comes to your mind about reducing unnecessary token usage?
Yeah, there's two big ones I
Mm-hmm.
think we've touched on during our conversation here. One is you're reducing governance risks. So by returning less data and exactly the right data that your AI needs, no more, no less, and you apply the right governance, so access controls and such, you're also reducing governance risk. In general, the more data you're sharing and making available to anything, whether it's an AI or a human or third parties, you're increasing your risk. You're increasing risks of data leakage, IP leakage, and so on. So reducing your governance risks and compliance risks is a big one. The second big benefit is you're more likely for your AI to be accurate and trustworthy. So if you're more assured that you're making exactly the right data available, no more, no less, and that data is trustworthy, then your AI is more likely to generate the right answers. You can be more confident in its answers. And if you're more confident, then the business is more likely to adopt and roll out that agentic solution more quickly. And then you realize the business benefits of that solution more quickly, be it more revenue or reducing costs in its own right. So those are the two big ones. It's reduce governance and compliance risk and improve trustworthiness and accuracy of your AI, resulting in more and accelerated business adoption.
Amazing. That was a great response. Thank you, Dominic. And thank you for taking us through this topic and covering the various aspects of it and breaking down the economics behind agentic AI. I think the message is clear for our listeners that as AI agents become more powerful, organizations need to think beyond the model itself and focus on the quality, the governance aspect, and efficiency of the context powering those decisions. So thank you so much for joining us for this conversation today.
Yeah, thanks, Neha, and enjoyed the conversation. Thank you.
Wonderful. And to our listeners, to explore the full economics behind agentic AI and to see how the ROI framework applies to your environment, read and download the white paper Lower Cost, Higher Trust, the New Economics of Agentic AI from our website. Until next time, keep innovating with data and AI.